Привет. Good to see you all. Pleasure to be here at St. Petersburg, Heisenbug. Very excited. So today I'm talking about the evolution of mobile test automation at Badoo. So we at Badoo, we started the automation in 6 years ago for mobile platforms. So from then, how and why we built end-to-end test suite that can take like 45 hours if you run them on a single device. So it's not a pure technical presentation. I try to keep some technical details of the tools that we are using, but if you want to know more about, we can talk after the presentation. My colleagues are already here. They can also explain the things. And it's not about the best practices. It's not about the steps to do a successful test automation. I want to tell you more about the story, how we evolved and scaled our automation at Badoo for mobile platforms. The reason why I'm doing this talk is I want you to correlate with your story with us and see where you are, like what you are doing good, what you can do better. So I hope my talk probably gives some points to think you, like what you have to do when you're going back to office on Monday. By the way, anybody's working in mobile test automation? How many? Can you raise hands? Good, okay. That's good. So it's me. My name is Sathish Gogineni. I'm a lead of test automation project at Badoo. Working at Badoo since 2012, basically from India. Now settled in London. I'm father of 2 kids. Nothing great. So my agenda is I want to tell you a bit where we are right now, and I want to take back to the 2012 when we started the automation, plus explain about what is the cross-platform test automation that we are doing at Badoo, and how we solve the various problems, like improving the speed, getting the reliability of the tests, and involving developers and manual QA into test automation, and 100% test coverage. I forgot what to say, but I keep you guessing until the end of the presentation. And we'll finish with the summary. So, to tell you about Badoo, Badoo is right now the purple with the heart symbol. We are kind of social, networking, dating, all these 3 words. I exactly don't remember how to combine this one, but we are in the mission to connect the people across the globe. So we almost have 400 million users, and we are 300K newly daily signups every day across the world. So in mobile, we have the biggest and the most important application for us is Badoo. Plus, we also have some applications which works on top of Badoo infrastructure. They work similar, but they are different. So like Badoo Premium, Blender, Hot or Not, and Fiesta. Plus, from last 2 years, we are developing the new generation of the applications. We are part of this development, Bumble, which is now quite becoming popular in US countries. And we have Chappy and Huggle. So we support all these applications, mobile applications. We support for both native platforms, both Android and iOS, and we release every week. Not for the sake of release, but we have the features that we need to deliver, and we want to release every week continuously. We also have the mobile web, supports some of these applications, and this we release every day. So a lot of experiments we used to do in mobile web and see if things are going good, and we develop these these features in Android and iOS. Plus, we also used to have Windows Phone, but when Microsoft said sorry to this one, we stopped developing the new features. But we still run some functional tests on the last released application to see that there is when we are releasing server every day, so not to break the application what we have in the store. So I want to tell you about the development flow we have. So it is kind of standard Git flow, but we have some, apart from master, we also have one more branch called development, dev. It's like a short term of the development branch. So we work mainly here. So when we have new features to develop, we create the feature branches on dev. and then we implement the feature, we test it, we run most of the functional tests, and then we merge to dev. And then we create the integration branch. We used to do like every 2 and 3 days randomly, but now it is automated. Like every day morning, we create the integration branch. We check what are the features that merged on yesterday. So we create integration branch early in the morning, and we run the functional tests and also some tests that are slow in nature, some tests that has to be run only on the device. So, and then we run these integration tests, so everything will be ready by when we come to the office and do some kind of regression testing manually to check that there's no integration bugs, and everything is good, then we'll merge to master. So the idea is to keep the master stable all the time and ready for the release anytime. And we create the release branch from the master. So back in time, we used to create like every 2 weeks, 3 weeks, but now we optimized. So we create the release branch every week to see everything is fine, then we release it. So, and the idea is to support all these release flow, to do the automation, to make the things faster and release faster every week. So in terms of test automation, what we have? So we have right now, we have like 400 plus functional tests, which works across 3 platforms. It supports 40 application developers we have on all these 3 platforms, and we claim that we covered 70% of regression testing with our automation, and we run almost like with our in-house infrastructure. We're not using on the external clouds, but in-house, like we run all these 3 platforms. We run like 65,000 tests per day, which almost takes like 1,500 man-hours. But we did the parallelization, and now our turnaround time for our automation is 30 minutes. So when a ticket is come for testing, we run most of the functional tests in 30 minutes and give the results back to the developers. So how we grow over the years? So as I said, we started in 2012. We did some automation, like pretty 6-7 months. We worked on automation, and then we decided to go with a cross-platform automation, and we started in 2013 May, and then we growing steadily, all three platforms. But the reason why I'm showing this one is because the growth that what we have last 2 years, lot of coveraging of our end-to-end regression tests. So in general, tendency is that you start the automation, but over the years, you need to spend more time on the maintenance of the tests. But for Badoo, we try to overcome these challenges and able to do the automation much faster. So that is one of the reasons why I'm talking here. So Windows Phone probably got the doubt why it's gone down, because once we say that, we stopped supporting this one, we deleted most of the tests, but we still run few tests every day to check the application is fine. So that was the story about the Windows Phone. So, okay, the next one is what we have done in 2012. So Badoo started working in mobile applications around 2009 and 2010. So by the time it's 2012, our application downloads are growing pretty good, and we are scaling the teams in company. So all the teams, all the developers for various platforms, they started growing, but most of the testing we were doing by the manual. And we decided, okay, let's automate the tests for mobile platforms. So I think I cannot say 100% that we ask the developers can they do the automation, but I'm pretty sure that if you ask them, they say that they don't have the time. It's not part of their responsibility. Even now, we are doing the conversation with them that it's the developer's responsibility to do the automation and all. But it becomes, the most important, it's become like a QA problem. Like we testing the things manually, we have a manual testers, and we want to make the things faster. So we want to start doing the automation. So that's how we hired a couple of automation engineers. I think I'm one of them, and a couple of my colleagues who joined mainly for both Android and iOS platforms. So in native platforms, so we started with, in 2012, we started with Robotium, which is a tool developed based on the Google instrumentation framework. And it was working quite good, actually. We was able to do the things automated in Android. Meanwhile, in the iOS, we have done a lot of experiments, tried, I think, most of every tool available back in time. Apple UI automation tool, tried also Eggplant that we tried, try to integrate these tools to done some technical, to overcome some technical problems. So we said, okay, we have the testing. We have automation testing for Android and iOS platforms, and everything looks good. Everybody's happy. There's no complaints about what we were doing, because we're showing that automation is possible, it's working and all. But then we got this question, why can't you unify the tests for these platforms? Mobile web is not in the picture yet. Basically, we try to target for both Android and iOS platforms. Why we can't be unified the tests? But there is a lot of arguments from developers, from different section of the people. Most of the arguments is that the application code base is different. It works, it's not the same locators. You can't write a code which can work for both platforms. The tools are different. And the behavior of the application is not the same. They are, I mean, now I see that most of the applications now, they're trying to develop these similarly across the platforms, but in 2012-13, they want to be deeply integrated with mobile platform features, like a back button, menu button, all these sort of things. They want to put these features into your application to get the more look and feel of the platform. So the behavior is different. Plus, internally, our application features are not the same. Like they're not in the sync. So different features on the different platform. Plus, you can't, if you're trying to unify the test cases, you can't use both application programming languages, and you don't get the support from the developers. So this is pushing back to do the unification, but we try to convince the people why we should do this one. One of the reason is that the design of the test is same. It looks exactly similar. When you have the idea from the product and you have the PRD document, what you design, what you want to test, even though on different platforms, the design of this test is it looks same or maybe similar. It almost looks similar, and the scope of the test is same. Plus, setting up the test data, to test that specific test, setting up the test data with server is almost the quite same. So Badoo have a lot of features, and one of the feature is that playing a game like swipe left and right. So back in time, it's more yes or no buttons. It's like the two people that they play the game, like both like each other, and then you get the match screen saying that you can talk each other. So to get this, to test this match screen, setting up a test data is quite big, because you need to create two users, and you need to have a photo, and the photo should be moderated and verified. Plus, you need to something else. So a lot of steps before you do actual test. So all this data, the server interaction is quite same. And this is a strong force for us to say that, okay, we should probably do the unification of the tests and develop this test for the multiple platforms. Plus, the difference is quite small. What you perform the actions and what you do the verifications probably bit different. So we said, if we can write the unification of the test, the team can be unified, can be work together and do the automation. Plus, you can optimize your efforts. You can do much more faster than like doing reinventing the same thing for the different platforms. If you merge, and you can avoid the repeatability of the things, and then you can do the faster. So all this leads to start the project, to the unification, and came to know that this is called cross-platform test automation. And we choose the Calabash. What is Calabash is, so now it has no longer support from Xamarin and Microsoft. They are looking for the open source community to support the tools, but the tools are still working. The Calabash is developed on top of the Cucumber, which is meant to be a BDD, behavior-driven development framework. So where we write the test cases in a normal language, like you can write in English and Russian at the high level. So all the test cases that you write, you will convert them into scenarios. And what the Calabash does is that they developed on top of the Cucumber, and they developed the protocol and the infrastructure to run the tests for both Android and iOS platforms. So we choose the Calabash for one of the simple reasons is that in 2013, there are not many open source tools if you want to do the cross-platform. This is the big reason. There are very few. One is Calabash, and one is the Appium. Appium was quite unstable back in time. So it's still in the, it was in the beta version, and we don't want to go with this one. Plus, we found that what the guys who are working in iOS, they found that Calabash is one of the best among the iOS automation tools. So rather than it is like a long research and choice, we quite pick up quite fast and say that, okay, we can do the unification and we can try with the Calabash tool. So that is how the team is formed, and we started focusing mainly on automating the tests. We used to help our guys to do the test manually, but once we said, okay, we do the unification, let's form the team, you have these goals, your goal is to cover the most of the backlog, most of the test cases that we test things manually, and also responsible for integrating your tools with the development process, with the CI, and run the tests, along with the development process. So this is the kind of architecture with Calabash, very pretty simple. So the top layer is where the Cucumber comes into the picture, like all these test cases that you want to write. You will write them in scenarios, set of steps, and then you implement the step definitions. So what helps us to, I mean, we have at the beginning it's like we have to use the Cucumber because we choose the tool Calabash. But what it helps us is that it helps us to separate your business logic from what you do on the platform. So most of your test cases you develop at the high level, which doesn't have any information related to your platform, and then you have this. Develop this page object model for both platforms, Android and iOS, and which has the code specific to the tool and which interacts with your applications. And plus, you have this all test data setup. You have the common module which works for both platforms. So this is how we started, and we learned, we almost spent like 1 year implementing the test cases for these platforms, not to think about other platforms, and we learned a lot of stuff like how we can write the cross-platform test cases. But then it comes into the picture of mobile web, like how we can integrate the mobile web into this infrastructure. Calabash doesn't support mobile web, but then we found the Appium. Appium supports the mobile web. You can run the test cases and integrate with HTML5. So we developed the test cases. We use the same test cases and put the Appium, and then started running the tests on HTML5. And later we also use the Selenium to run the tests on your emulator browsers. So with this after doing the mobile web page, our code is much more structured, modularized, and we are ready to take any more platforms that we need, and we're done with the Windows Phone. So back in time, we have almost like 5 million users in Windows Phone, and we thought we do the automation and use the Vinium tool and then interacting with Windows Phone. So this is the how that we evolved over the 2 years, creating a cross-platform for all the mobile platforms. But the most interesting thing that we didn't think in the beginning is the infrastructure that we need to build around these tools to run the test cases on the CI and reporting and reports and all the stuff, because the tools this layer is become like just a plugin. If you want to change for a specific platform, you can change and use some other tool. But the most of the infrastructure that what we have is common, and based on the Cucumber, based on the Ruby. So all the infrastructure that we need to develop over the years is become much more simpler because we are using the things common between the platforms. What we have achieved, so we are responsible for one thing: test automation, test running on CI. Test count is growing, finding some regression bugs, and sell the idea of okay, the test automation makes sense. But most important advantage what we have within the team is that we are sharing the knowledge between us. So we are the people who worked in different platforms, joined company, started working together and sharing the knowledge across us, and it create a huge learning curve when we expanding the when we are adding the more platforms to the project. Plus the teamwork and resource sharing, when we have some features needs to be developed for a specific platform, we work together and try to automate them fast. That's the way we started things, but we got various problems. So first and the most important is the speed. We become slow and slower. Not because of the cross-platform, because the more and more tests we are adding to the project, they are becoming slow. And it's mainly because we are not running tests parallel. We are running on single thread. So the more and test suite that it is growing, we running tests. We come up with some weird ideas of running tests, like running some smoke test suite on feature branches, running some part of tests on integration, running full functional tests like nightly or on release branches. But this is not completely solving the purpose of test automation. When you have test automation, you need to be early in the process. Try to run these tests as early as possible to remove the all manual testing that you are doing. So because of the slowness, all our manual testers, they're testing almost everything on the feature branches, and we are finding some bugs which they didn't caught up. So we want to fix this one. So we want to run the test parallel. But the biggest problem is that Calabash doesn't support the parallel. It means that Cucumber itself is back in time. They don't have this. They don't have the concept of doing the parallelization within the tool. So we want to speed up. So we thought have to do the parallelization. So we started with Android platform. So there is a gem, parallel Calabash Ruby gem, which developed on top of the Calabash, which works for the Android. So we expand our device lab to run the test cases parallel, and we started running the parallel. The most important is that what we got is that we hired the person who actually written this parallel gem. Is Rajdeep, is now in Badoo. So, but running tests on devices solve the issue temporarily, but the more and more tests, we need the more speed, right? So we couldn't able to expand the, we couldn't able to depend completely on the devices because the physical space of the, the device lab that what we thought is good enough is full. We don't have any space to add more physical space. Plus the device maintenance. So we have very small summer in London, but when that happens and we're running tests continuously on devices, the batteries become huge, like bulge, and stop working. The devices stop working. Plus the network and all the stuff. And the other thing is that cable health. The more we adding devices, we need to manage our cables beyond this beautiful device lab. So all these say that, okay, running tests on device is good, but not good enough to achieve the speed. So what we have done, we use instead of the devices, we started using the Genymotion. One of the reasons is it has a Google Play, which is a mandatory requirement for us to run our tests. Plus, it was back in time, it was the fastest emulator compared to the Google one. It's because it has the x86. It was the first emulator which developed on top of the x86, and that makes things the faster. And Google has the ARM capability, which things make slower. And we introduced the concept of Dockerizing to make the things easy to do the deployment, and things looks good. And then later we switched to Google emulators once the Google released the x86 stuff. And it is a smaller image compared to the Genymotion. Plus, it's a headless, so it requires less hardware resources, and it has no license cost. And so that makes the things what we want to achieve. So today we have like bunch of Linux servers. They are like 56 core and potentially can run like 32 emulators. Each one costs like £6,000. We want to be we still want to be thinking like how we can optimize the emulators to run the test faster, but with this one, and it's easy scalable. Like last time when we want to add more Linux machines, it doesn't take like more than 2 days to put everything in place. With this one, things become faster. Like we are running our 1100 tests in 20 minutes. So we're running in all feature branches. We're finding all what we can find with the functional tests through the automation. Plus, we're still running tests on nightly to some of the devices that we want to still see that everything is good. Most of them, they are Samsung anyway. And that's it. And while we are working with Android, we also worked with the mobile web. But mobile web things become quite easy for us because we extend the parallel calabash, extended for mobile web. Selenium Grid makes things easy for us to do this one. And we started running tests on emulator browsers, so stop using the Appium to run the tests on devices, completely using the switch to Selenium. Plus, it requires fewer resources compared to the Android. So now we have all these tests that what we have, it took like 15 minutes. Plus, we have no regression testing for the releases. As I said in the beginning, that we release every day, so we completely remove the manual testing, and they release every day. Yeah. And that is about the Android and mobile web. But the next and the most interesting and complicated is the iOS platform. So iOS is always the nightmare. So we can do the parallelization on the device, but running tests on devices is quite flaky. They always get the alerts. The network is quite dropping and all these problems. And so we prefer the simulators actually from the beginning. The reason why is that because we didn't find any bugs that can only reproduce on device, but not on the simulators. So we have tests that has to be run on the devices, and we're still running on iOS devices, but most of the tests, we prefer to run them on simulators. The one issue with what we couldn't able to do for Android and iOS is the Xcode instrumentation. What we have for the in the back in time, like two years ago, they don't support the creating the multiple simulators and the instrumentation. It is a singleton and doesn't work for the multiple simulators. So this was stopping us to able to do the parallelization how we did for Android and how we did for Android and iOS. We couldn't able to do it for iOS. So what we have done is that since it doesn't support the multiple simulators on a single desktop, we created multiple desktops on one machine. Like if you have a Mac Mini, you can create up to 4 desktops, and you have one simulator per desktop, and we're running tests through the SSH, running tests, getting the results, and creating the reports. And then to get the more speed, we create the multiple cluster, the multiple hosts, and then the multi-parallel testing, and get some up to some speed to get the things to achieve the speed what we want. But creating multi-desktops is quite flaky. Even the Apple, when you're creating each desktop, every time the app, you have the Apple alerts, the desktop alerts, and you need to create some Apple scripts to touch these alerts, and it's quite flaky. And simulators are, because of when you're starting the multiple desktops, it is always fighting for the hardware resources, and then simulators often getting stuck, and you losing the simulators. So we keep fixing the issues, keep fixing this flakiness, but then finally, Xcode finally started supporting, instrumentation started supporting for multiple simulators, and we said, okay, we can do, we can do now the parallelization like what we've done for other platforms. But the biggest issue with the Calabash has its limitations. There is a run loop module which actually using the Calabash, which is written on top of the UI automation framework. So mainly use it to do some touch and scrolling operations. All rest of the things, they use a server module that is injected into your application and sitting as part of your application and do all the things. But only this part to do the touch and scrolling operations, it has a UI automation. It has developed on top of UI automation, and it has the limitations to run the things. So what we have seen, the alternative solutions is that there is a driver that Facebook released, Facebook web driver, which is written on top of the Selenium protocol, which you can automate your application with this one. Plus, it has the support for the multiple desktops. So we thought, okay, maybe we can use this one. But one thing is that Calabash is not a standard Selenium protocol. So the query language is completely different from Selenium. So migrating from Calabash to Facebook WebDriver costing a lot of money. Plus, WebDriver doesn't support the backdoor concept. The backdoors is one of the popular concept in the Calabash. What the backdoors is that you can invoke your application code through your test cases. It's not a advisable thing, but it helps for a lot of things to automate some complicated features or to speed up the tests. For example, if you want to test something and you don't want to do the login for every time, you can inject, you can open the application with authentication key, and it's speed up your test cases. So we using the backdoors in our automation, and this makes we can't migrate to this one because driver doesn't support of its framework. And Calabash is faster in most of the cases because it has a server inside your application, and do most of the operations. It is quite faster compared to Facebook WebDriver. So what we have done, instead of migrating to completely, we merge both Calabash and Facebook. We called it as a hybrid solution called FaceBash. What we have done is that remove this run loop with the Facebook WebDriver. So we keep most of the code common, which the way it is working before, and using the Calabash server module in your application. But the Facebook WebDriver, replace this run loop module with the Facebook WebDriver, and that allows to get some speed. So it has a fewer desktops and more simulators. Plus, it is relatively stable compared to what we have. But we still far from the target speed for iOS because it requires a lot of hardware to get one simulator. So I'm stopping about the iOS right now because Nick from our team who worked about improving this infrastructure, this one, and he's going to talk about his talk tomorrow, almost at the same time, in the same room. So he's talking about like how we develop the remote iOS device server to achieve this speed. So we achieve, with doing this one, we got the speed what we want in iOS, and we're running tests on feature branches, similar to other platforms. The next one is, once we got the speed, the other problem that we have with the test automation is the reliability of our tests. So by nature, end-to-end tests flaky. Everybody accepts this one. They can broke any time. And more tests we're writing, it's creating the more flakiness. Plus, the tests are quite often broken with the application changes. So we're running the tests on feature branches, but if the tests are not broken because not bugs, they tend to merge their code, and then the more tests were failing. So we are chasing to fix the tests that are broken already in the development. So all this caused to us to having the no confidence on the tests. So what we found is problem is not with the code. Most of the problems is with our culture. Like we focus more on trying to write more and more test cases, but putting less focus on fixing the test. And we want to improve the stability of. We have less focus on the stability. So we want to improve the stability. And what we have done is that, okay, let's have a target ourselves. Let's make 95% of our tests should pass, and let's do what we need to do. So why the better goal is because we thought at least in the first one we should achieve at least this target. So we create so fixing the failed tests become our top priority rather than automating the new tests. And we said we are a cross-platform test automation, but we have people who can be responsible for each platform and see that how many tests is failing every day in the morning. And if the tests are failing more than 5%, then report them as a red, and let's try to fix them. Let's get a green results on your dashboard. So this makes us to motive towards to fixing the tests, and started fixing the tests. And also we said, okay, we can't merge the feature branches if you want to depend on our end-to-end tests. So if the tests are broken, first let's fix the tests, and once that is done, let's merge your application changes into the dev. So these steps makes us to get some stability. And then we said, okay, it's time to stretch our target, make the more tests. 99% of the tests must pass. What we need to do next? So as part of solving the speed and speeding the things, we also improve the stability of our infrastructure, create the monitoring, creating the monitoring of things like if something is broken, let's get the notifications and try to fix these problems as soon as possible. Plus, we also found that our server infrastructure, what we have for the applications, that we run tests on staging servers. So they're not meant to be run these many tests, and some of the modules are quite slow. So we work with the server guys, server teams, and IT ops team, and we improve the server infrastructure and to make the things much more stable for us. Plus, creating the better APIs, spending time to create the APIs, to create the test data, so things works much more reliable. All these steps, we were able to get up to a decent speed. So this is one of the snapshot I took like a couple of days ago. So we have, it's still not green, still red, but we have like 1 or 2 tests are failing, and we were able to live with these failures. So when we have less failures, everybody said, okay, it's fine. Because we used to have the green builds, but I couldn't able to get it in last week. Okay. The next one is how to involve the developers and manual testers into this automation. So first thing is developers, because they speeding up, we are finding the bugs, we're finding the issues that what they're broken, but they don't have no idea about our test cases. they see it as a black box, the way we see their application. It's because it has different tools, different programming language, huge set of instructions to run the test locally. So all this makes them not to depend on the test that what we are writing, and we have to spend a lot of our time to analyze these failures, reporting these bugs. So we want to fix that. We want to bring the developers to using our tooling, our tests, to analyze their the changes, what they broken in their things. So what we have done, so we Dockerize our test environment, make things simple for us, for them to run the tests. Plus all the reports, what we do, how we show them, like in TeamCity, we put the Docker commands. So and then we created the documentation, how to debug the tests and all. So all these encourage them and started using our test cases, started checking that why some tests are failing try to reproduce the bugs that what they are fixing. So this gives good results. One thing, they're checking the failures. Some even fixing our test code because of the broken by their changes. Plus, they are deploying the tasks without the need of manual testers or automation engineers. They do the things, they run the tests. If all good, they deploy to the production. They merge to the master without any help of the QA. So it is saving a lot of our time. The second one is involving the manual testers. So one of the problem, because we separated from them, we created our own team, and maintaining by ourselves, they lost the responsibility. They lost the responsibility of these tests. They think that it's not their baby, and they never got the confidence of what the tests we are writing. It creates the two problems. The one is they're testing what we automated, and they're wasting their efforts in doing the things manually. Plus, we are not gaining their awesome knowledge that they have got on the QA. Like they got the good knowledge of what to automate, what not to automate, and we are not gaining their knowledge to make the things better for us. So we said, okay, it's time for review. We need to do something about this one. So what we have done, we involved them. We said, okay, do the reviews and see what are the problems we have. Like why you think that these test cases are not useful to you. And they come up with missing flows, what is not covered, and things that are not supposed to be tested in the test. One of the test cases what we haven't done. So by adding the flows what they asked and improving the test verification, so it improves the quality of the test. I thought that this will bring them to to do the automation, to start using this one. But they asked this question, like, what is your coverage? Which is, quite difficult to say like what you covered, So you have a feature, you develop some test cases, and you say that, okay, you covered this 100%, but then they come up with like why you didn't automate these test cases, why you didn't see that this feature created. You said this feature is automated, but then we found some critical bug. So we want to know that what is actually we covered. So what we have done, so we said, okay, let's add them. If some test cases that we are not covered, and it's important for you, it's important for you to think that you should automate this one, let's add them as to-dos. So these test cases looks like test cases, but they are not. They are commented, and they said like as a to-dos. And if there is new features, add them as to-dos. So we are gaining the knowledge of them, like what test cases should be automated. And we said this is the coverage. The number of test cases that we add automated in the platform, plus the number of done, plus to-do tests. And then we extract all this information from our test cases. We created some Excel sheets, and then we are showing these charts, like what is automated and what is not done. And same for all the platforms. So this brings, and then once we've done these platforms, we thought that, okay, why don't we also extend for the components that we have internally in our application, and to see how much you covered based on the components. So it's a simple test scripts where you extract the data and create the Excel sheets on this and create these pie charts. So it's much more visible to it. So what this helped is it brings the transparency. It brings the transparency between us, like what is automated, what is not automated between the platforms. Plus, it brings the confidence. It helps to drive what to automate, which component we should automate, which component we should focus more. For example, if you have the product is more targeted on features on specific to specific component, so it means that it's better to automate the things related to this component first. Plus, it became like our baby. Like we are, become like a QA. We are part of this project. Everybody is responsible for this one. So they are also analyzing the failures. They're fixing the tests on the things which are broken by application, but they can do the things. And once they started writing to-dos, they got motivated and then working together. So they have started automating the new features. So it makes our team, like test automation team, get some space to do much more better things for our project. So we started thinking about developing the new tools, like on top of the test automation, what needs to be done, like in improving the frameworks to make things faster, easy for everyone to do the automation. Thinking like why we should run full functional tests on feature branches, why we can't do some, like what Simon's saying, creating some graph and see that what tests actually we should run on each feature branch so we can reduce the number of test cases to be run. And still trying to automate the complex features, trying to find the solutions to automate the features that once we think that it's not possible to automate. Okay, so probably got the doubt, like, okay, all this test coverage, trying to bring the confidence to the developers. Are we heading to the 100% test coverage? Indeed, we kind of going in this direction, and we realized that it's not a test pyramid, and it's an ice cream sandwich, and this can be melt. So we started working on this one, see like what we can do, because doing 100% coverage through the end-to-end test means is definitely not a pyramid, it's definitely ice cream. So we started working on this one. The big, like what we have in mobile platforms, we have the unit tests writing by developers. The biggest problem is that we don't have the integration layer. We never look back and say that, okay, why we don't have the integration layer. So we kind of realized that not doing the 100% coverage through the end-to-end test is not the best way to do, and creating the integration layer. So we are working on it. We're trying to develop the tools with the developers, creating the frameworks to do the integration tests for mobile platforms within our framework. And the idea is to, once we create the integration layers, these tests can be done by developers, and we move slowly our end-to-end tests to the integration layer. So this is the plan. This is what we are currently working on it. And that is pretty much. So what is, I want to give the summary of my talk, like the purpose of the talk is that choose your test strategy. Think about your test strategy, whether you want to do the cross-platform. If you have, even at mobile, even if you have a desktop and some mobile applications, think about why you can't do the cross-platform or why you need to do the platform-specific. Plus, align with the development process. The more you put your automation project, keep with the development process and running the test as early as possible, it gives the much more value to your test cases. And don't ignore the flaky tests. Keep, whatever end-to-end tests you have, even you create the pyramid structure, but still your flaky test has no value, so make them stable. Faster feedback, parallelization, even for us now 30 minutes is quite reasonable, but maybe we should do them much more faster. Plus, involving the developers and QA is crucial, is what I learned from my experience. Never thought that a test automation is your code and nobody should touch it. But the more you involve them, things become quite faster. Spend your time on infrastructure and encourage the unit and integration tests. So we need to initiate the conversations with your developers and create a test pyramid model. Yeah. So Alan Page said in the Heisenbug Moscow that test automation engineers will disappear. But this is my feeling. Like they won't disappear. We will exist, but you can do much more than doing the automation tests. You can influence your organization to make the things, what you need to do to make your quality of the product is good, make the releases faster. And thank you very much. Thank you for my team who is doing all this amazing job. Any questions? Yeah.
Okay.
Hello. How many developers is in your team, and how many manual testers and automation testers?
This is the automation team we have, like 8, 9 people, 10 people we have, but we still have one person responsible for one platform. So we have this team is because we have different applications. So we have Badoo, we have Bumble, which is completely different. So we have 40 developers, more than 40, and we have 10 automation engineers. And we have
manual testers?
We have, I think, 15, 22.
Thank you.
Yeah.
Okay, one more question.
Hello.
Hello.
Thank you for the talk. I have one question. 30 minutes is still a long time.
Yes.
When do you run your tests? After commit, it's...
So we have these future branches. So when developers said, OK, I'm done, everything, and then he pushed his code, and then he moved his ticket to a state called resolved state. So when or review state. So when the ticket is in review or resolved state, we trigger the test for this platform. So the idea is before the review is finished, we will get all the results back.
Is this automated?
It is automated, yes. So we have a release engineering team who helped integrate with Jira we have, and it is automated for all the platforms.
Thank you.
Any more questions?
There's one gentleman here. No?
I already heard the answer.
I see, okay, good.
Okay, I can see one.
You said that is automated links with, let me say that more clearly. If your test on release branch is failing, you automate this process, but what do you do with flaky test?
We try to fix as much as possible. I mean,
so
on the release.
I am a developer. I have branch on which some of the tests failed.
Yes.
And this test may be flaky.
Yes.
If process is automated, how do I know that that branch is okay?
So we trigger the tests and we report the results back to the developer, but we are not reopening the tickets automatically when the test failing.
So manual analysis is crucial.
Sorry?
Manual analysis
yeah. So we still check the still check the tests, see
okay,
why this failed. So we explained this. So it's nature, like when we have all these automation tests, developers expect that, okay, I don't want to see the failures that is not related to my code. So we always get this question, like why I see some tests failing. So what we do every time, we see that we explain them the reasons why. We explain the nature of the end-to-end test, and we say that it is the responsibility of both developers and us. So if you see some flaky test which is not related to your code, but still try to investigate and see where is the problem. The problem may be with the server, problem may be with some other thing. So you have something to say?
Wait.
So first, these awesome guys added a very nice bug to the stack trace of flaky tests. So when you unfold it, and if we detect that this test sometimes pass, sometimes fail, they add bug to the stack trace. So first you can understand that it is flaky, and it's you can rerun all your failed tests like in less than 10 seconds. You touch one button, give a link for failed tests, and in several seconds or minutes they would be run. So developers can also run them.
Yeah. So yeah, I mean, if developers is lazy to not to check the failure tests, what they do is that we put the things to rerun these failed tests and run them, see that if anything is related to these changes. So most of the times when you rerun the failed test cases, they get passed. Plus we also put some visual indication that if the test is already broken, become flaky, so we are. If the test is never flaky and failed only on this branch, we are highlighting with some colors, like in the team city. So to see that this looks like a bug. It's not a flaky test; it's more look like a bug. Yeah.
Hi.
Hello.
On one of the slides, you said that now you're working on improvement of integrated test.
Yes.
And in your presentation, you divided end-to-end testing and integrated tests. And I thought that end-to-end testing includes integrated testing.
No. So these are completely. All are what we have right now. We have unit tests, we have the end-to-end tests. All the end-to-end tests are not, none of them are integration tests. They are using the complete stack of the things, and they are pure end-to-end tests, yeah. So we don't have the integration tests yet, but the idea is to bring the integration layer first and moving end-to-end test to the integration layer and delete them at the high level.
Unit tests and integrated tests, that's something like similar, yeah?
At least for mobile, it's quite different. At least what we understand. So what we want to achieve is, so what we have unit tests is even mocking the complete UA of the mobile. So and they don't have the interaction between the components of your mobile application. So they purely test their code through the JUnit tests or XUnit tests. What we want to achieve with the integration layer is that we want to write the test which can interact between the components in your application and mocking the server, mocking server completely. So it is one more higher level than unit tests, but when you're doing the server mocking, your tests can be much more reliability. Because a lot of tests we don't need to interact with the server. They can be done. The same flow can be done in the integration layer between the two components. But right now we don't have that framework. So.
Okay, so integrated test will be developers or testers will write?
Yes. We want the developers to write these test cases.
Okay.
So how to mock the server? Because server is releasing like every day. So how to mock the server and still create this integration test is what we want to achieve. Yeah.
Okay.
Okay.
Thank you, Sathish, for your talk.
Thank you very much. Spasiba.